All right, so this is the second half of our lesson. So we're still in P.1. We're going to now go through a real number line and inequalities. So I'm sure you've seen a real number line before, so this is just review. A real number line is a graph. It's a two-dimensional graph that is, sorry, one-dimensional graph that is used to represent the real number, the set of real numbers. A arbitrary point called the origin is going to be labeled as 0. So right there's my 0. The distance from 0 to 1 is called a unit distance. So you may have done this at one point in school, you counted by unit. So unit distance. Numbers to the right of the origin are positive and numbers to the left of the origin are negative. On a real number line, the real numbers increase from left to right. Like I said, may not need it all that, kind of worth going through quickly. All right, so the following symbols are called inequality symbols, and these symbols always point to the lesser of two real numbers when the equality statement is true. So usually when we write our inequality statements, sorry. Let's try to move stuff here. A lot of times we like to write the variable first and then the number. So you might see these, like I said, you see some flipping here. So we have A is less than B. We have A is less than or equal to B. We have A is greater than B, and we have A is greater than or equal to B. So these are all true if we write something that's true. So true versions of these statements. Well, 3 is less than 5. 3 is also less than or equal to 5. You can also say 3 is also equal than or less than 5. So those are also true statements. A is less than B, so 7 is greater than 5. Or we can have A is greater than B. Well, 7 is definitely greater than or equal to 5. And we could also say that 7 is also greater than or equal to 7. It's just an example of how these work. So when we compare the size of real numbers, we say that we are ordering the real numbers. So we want to determine if the following statements are true. Is 9 in fact less than 12? True, this is a true statement. Is 9 in fact less than or equal to 12? Well, that's also true because it is at least one of those. So this one, as long as it's one or the other, we're fine. Is -3 greater than -1? Well, this is why we have that number line to help us think about this one. One, two, three, four, five, six, seven, 8, 9, 10, 11, 12. So, like I said, these numbers are always ordering like this. So in fact, what we have is -3 is actually less than -1. So this is a false statement. Like I said, might seem a little silly, but we're just kind of quickly hitting these things. Makes it a little more complicated. Determine if the following statements are true. So this is closer to what you see in your homework. So what we need to do here is we have a expression here. We know this represents a singular number. We want to know, is this expression actually greater than or equal to 0? Is this expression here actually strictly less than 3? So take a moment and work on those, and then we'll come back. All right. So let's do A first. So we're only worrying about figuring out what this actually is. So we have a grouping. We have 2 minus 3. So that is 4 times -1 now, because 2 minus 3 is -1, plus 6. We want to know, is that actually greater than or equal to 0? So 4 times -1, because now we're up to multiplication divisions, my next operator I have available. Well, that's going to just be -4. So -4 plus 6. Is that greater than 0? -4 plus 6 is just 2. Is that greater than or equal to 0? Yes. This, in fact, is a true statement. All right, so here we have the inequality. We have 3 times -2 squared minus 5, and that 2 power 3 minus 5 is in parentheses. So we'll do the top grouping first. So we got 3, 2 times 3 is 8. So we went inside of the grouping, and then we do the next operator in the grouping, which is the exponent. Next, we have this grouping where we still have to work out. So we got the 8 minus 5. Well, it's going to be 3 again. 3 times 3, well, that's just 9. So now we have 9 over the grouping, which is 6 divided by 2 plus 3. So if we do the bottom grouping, going left to right, because we just have multiplication division, we got division first. So this is going to be 9 over divided by 2, which is 3. So 3 times 3 got less than 3. So 9 over 3 times 3, that is going to be 9. So 9 divided by 9 is 1. Is 1 less than 3? True. But you're thinking that was going to be false because the other one was true. Nope, they're both false statements. I mean, both true statements. All right, so absolute values. So I know we did a little bit of this, so we're just going to go back through it again. So an absolute value of a real number, A, is denoted, and that's a typo here, would be denoted as absolute value. And this represents your distance from 0 to A on a number line. So there's 0. So let's say A was 3. This distance here is 3. So the absolute value of 3 would be 3 because it's that distance from 0. So if you looked at -3, absolute value of -3 is also a distance of 3 from 0. So that's also 3. So the point of absolute 0 is supposed to represent, or sorry, absolute value is represent your distance from 0. So this is trying to tell us the same thing. This is called a piecewise defined function. We will see this again. But absolute value of x is that it's going to be x if x is greater than 0. It's going to be negative x if x is less than 0. Basically, this is assuring, once again, let's say x was -3. Well, then here it's going to stay 3. And here it'll turn back to 3. If x was 2, then here, oops, sorry. Then here it would be, I did that backwards. Let me go backwards just a little second here. Let me explain that formula one more time. So if x was -3, then we would go here where x is less than 0, and this tells me that we'd have -3, which is 3. I went too fast last time, sorry. If x was 5, then this would say, well, x is a positive number, so x stays 5. So basically it's ensuring that the number stays positive. The absolute values are positive for any quantity. So we're going to go simple first and make them more complicated. So we rewrite each expression without absolute value bars. Okay, so if we have 4, the absolute value of 4 would stay 4 because 4 stays positive. If we have absolute value of -4, that's also 4 because 4 has to stay positive. Where it gets tricky is a situation like this. We have 1 minus the square root of 2. So, the square root of 2 is approximately 1.414. So in its current state, 1 minus 1.414, this is going to be a negative number, and we want a positive statement. So if you have a smaller number minus a bigger number, and you want to write it so it's an absolute value, you're just going to switch the numbers. It's going to be the same values, just now it's positive. One of the things that you're going to need going forward is look at statements and think about how can I rewrite them. So in this case, we still have the exact solution. But we have the exact solution, but written in the way that we want to be expressed. We want to express the absolute value of 1 minus the square root of 2. Well, if we want to do that, we just flip it and we put the larger number in front. All right. Here are a couple examples of this. We have absolute value of pi minus 3. How can I rewrite that? So it looks like absolute value. And then this is a little trickier. We have absolute value of negative 3 over negative 3. Okay, maybe not that much trickier. What would that actually equal? Oops, sorry, I had one more. This was actually going to be problem number 6. I took out some problems. So just where we are. Let's pause for a second and work on these. All right, so for A, pi is roughly 3.14. So in this case, we have a larger number and we're subtracting a smaller number. This statement right here is already positive. So unlike the other case where we had 1 minus the square root of 2, because the square root of 2 was bigger than 1, we had to do the flip. Here we don't have to, because this is just going to stay pi minus 3, because that's still going to be a positive value. So it goes from positive to positive, nothing needs to change. B, we have absolute value of negative 3 will just be 3. So now we have 3 divided by 3. That's going to equal just negative 1. The distance between points on a real number line. If A and B are any 2 points on a real number line, then the distance between A and B is going to be given as absolute value of A minus B or B minus A. So distance is always positive because you never talk about a negative distance. You never say, hey, I live negative 5 miles from here. You would say, I live 5 miles from here, a positive value attached. So all we're saying here is that when we represent a distance between any 2 points, it needs to be represented as a positive value. So we want to find the distance between negative 4 and 5. We want that distance. We said A and B. So we either can say it's negative 4 minus 5, the absolute value, or we say it's 5 minus negative 4, absolute value. So remember A minus B or B minus A, doesn't matter, absolute value is going to make it come out to something positive and the same value. So negative 4 minus negative 5 is negative 9. The absolute value of negative 9 is 9. 5 minus minus 4, well, that's just 5 plus 4. So we're going to absolute value of 9 again, which is going to be 9. Either way, this distance is 9. All right, so take a moment here, find the distance between the following 2 points, negative 8 and negative 3, negative 4.5 and 9.4. And this is question 7. Okay. So we have, like I said, A and B. Okay, sorry, I said something weird. I was doing this recording. So -8 minus, because remember, it's absolute value of A minus B or absolute value of B minus A. Everyone you want to choose. So I can make it easier doing one or the other. So -8 minus -3. So we got -8 plus 3. The distance is going to be -5. So the distance is just going to be 5. So you might need a calculator for this one. Once again, A and B. So you may want to do B minus A this time. So we would just do 9 minus 4 minus -4.5 absolute value. So this is 9.4, really it's just plus 2.9. So you're going to get 4, 13.9 absolute value. So the distance here is just 13.9. Okay. So my last little bit here is going to do properties of real numbers. So you may have heard these properties before. We're just reviewing them. So we have commutative property of addition, which is A plus B equals B plus A. So commutative property of addition just basically says that if I'm adding two numbers, I can flip them. So it's commutative, meaning you can move. Commutative property of multiplication, A times B equals B times A. Once again, commutative property, you're thinking we can move. So 3 plus 2 would be the same thing as 2 plus 3. 3 times 2 is the same thing as 2 times 3. All we did was just move the position of the numbers, but still comes out the same. I always think associative property is like who you're talking to, like who you associate with. So associative property of addition, A plus B could be associating, and then we'd add C in later. Or we have A plus B plus C are associating first. So what it's just saying is that I can do B, then add C, or I can do D plus B plus C, then add A. So if I had 3 plus 2 plus 5, well, it's just going to be 5 plus 5 and it equals 10. Well, that'd be the same thing as if I did 3 plus 2 plus 5. So you have 5 plus 5, that's 7 plus the 3, going to equal 10 again. Same thing as social property of multiplication. I could do A times B, then multiply by C, or I can do B times C first, then multiply by A. So this would be 6 times 5, which is going to be 30, or I could do it this way. 3 times 2 times 5. 2 times 5 is 10, times 3 is also 30 again. Okay. And you can do combinations of commutative and associative property together. So with the combination of these, that's also telling me that if I had 3 plus 2 plus 5, I could put those together, but I could also do 3 plus 5 plus 2, so I could use that commutative property and flip it. And it also tells me that I can do 3 plus 5 together plus 2, so do the associative property. So you can do combinations of these. We also have the distributive property multiplication over addition. So I have A plus C and it's multiplied by, sorry, B plus C and it's multiplied by A. Well, then I can just do this, A times B plus A times C. So if I had 3 times 2 plus 5, that's the same as saying I have 3 times 2 plus 3 times 5. Sorry, it's catching weird right now. So this would just be, like I said, 3 times 7. So this would be 21. This is saying that I have 6 plus 15, which is 21. Sorry, I'm having a lag problem right now. The identity property of addition, that any number plus 0 is going to be that same number. 3 plus 0 would still be 3. Identity property multiplication, instead of 0, it's going to be that 1. So 3 times 1, or A times 1 is A, same thing as 3 times 1 is going to be 3. So these two properties are kind of helpful because they tell me that no matter what number I have, so if I have 5, 5 secretly has got a 1 multiplied to it and secretly got a 0 added to it. So that carries with every number that they carry they're multiplied by 1 and an addition of 0. And that's actually how we do a lot of our algebraic manipulations. So the inverse property of addition, A plus negative A is 0. So if I have 5 plus negative 5, that would equal 0. That also means if I have negative 7 and I want to be 0, then I add its inverse to it. So what's negative 7's inverse? Well, it's just positive 7. So it works both ways. The inverse property of multiplication, A times 1 over A is 1, or 1 over A times A is 1. So if I had 6 and I multiply it by 1 over 6, that equals 1. If I had 1 over 6 and I wanted to get 1 back, I just multiply it by 6. There are also the properties that we use when we're trying to solve equations as well. Okay, so for example, we want to select a property that's illustrated in the given equations. Okay, so we are going to, we have 4 plus 3 plus negative 2, and now we have negative 2 plus 4 plus 3. So we have these two numbers together, and then this 2, and then this 2 switched out in front. So we have addition, and we have something that moved. So this is commutative property. Here, just a second. Not sure what the lagging's about, but it's commutative property of addition here. Here we have 3 times x times y, and now we have 3 times x, and then we times y. Or sorry, the 3 times x times y together, and then the 3 times x together times the y. So we got multiplication here. Also, what we see is we change the grouping, who groups with who. So this is the associative property. We'll type that again. Like I said, we got associative property, we got multiplication, associative property of multiplication. We have 2x minus 2x equals 0. So if you remember this property, if I have 3 and I add negative 3 to it, it gives me 0. Well, that's the same property we have here. We have 2x plus minus 2x. So what we have here is the property where we find an inverse. This is an inverse property, and we got subtraction or addition as we changed it to, so inverse property of addition. Okay, so I think this is maybe 8 now. I want to select the property that illustrates the given equation. So we have 5 times x plus 2, and then we have 5x plus 10. Then we have 1 over x minus 2 times x minus 2 equals 1. So determine which one of the properties these are. Hopefully the lagging will stop here, but we'll see. Okay, so what we see here is we have these two numbers add together, then it's multiplication. So we have 5 times the x, and then this 10 would be the 5 times the 2. So we have distributive property. This is distributive property of multiplication over addition. So usually we're just going to say distributive property, especially going forward when we start using this property a lot more. So here we have a number. So if you remember, we had this one that was, if we have a, I think it was b, but if we had a and we multiply it by 1 over a, we get 1. And if we had 1 over a and we multiplied it by a, we get 1. This is an inverse property again. So I have x minus 2 and I have an x minus 2. So 1 over x minus 2, like we have here, times x minus 2 equals 1. So we got multiplication and we have an inverse property. Inverse property, multiplication. Okay. Terms, the number next to or in front of a variable is going to be called a coefficient. So if I had 3x, sorry, let me do that again. My stuff got crooked. 3x plus 2y. The coefficient would be the 3 and the 2. Those are coefficients. If a term does not have the same variable present, it is, or sorry, if a term does not have a variable present, it's called a constant term. So if I had 5x plus 2z plus 6, this term here would be the constant term. This is the only one that doesn't have a variable attached to it. The parts of each term that are being multiplied are called factors of the term. So 7x has the factors of 7 and x. 5x has the factors of 5 and x. Well, let me do the other ones. 2z Factors are 2 and z. And technically the 6, it has a factor, so those are going to be 6 and 1. There's other factors we can have. Like I said, this is just some examples, but if we could take a number and we can break it up into two numbers that multiply to give us that number, those are factors. We'll do a lot more with factors as we go forward. Terms. The terms of expression are the addends of the expression. So what it means the part that we're adding and subtracting. So each one of these parts, the 5x cubed, x squared, 32x, 5, those are all going to be called terms. They're just different terms. So you can have a constant term. So each section in the box, like I said, represents a term. The number next to it or in front of it is going to, oh, that's a repeat, of the number is going, or the variable is your coefficient. The one that doesn't have a variable is your constant term. I was mistaken my slide here. So like terms have the same variables raised to the same power. So basically everything but the coefficient should look the same. So the two we see in the yellow boxes here, those are like terms. Oops, sorry, I just lost my tool. There we go. So what we see here is that we have 6x squared. So it's just this x squared that we're worried about. This is just x. It doesn't have the square, so it's not the same. This has a square, but it's a y, so that's not the same. And this one's not the same. The only one that has that same little expression there, that x squared, that is the other one that's a like term. So examples, expressions, simple. We're gonna simplify the expressions by using like terms. So when we say we simplify using like terms, it means that we're just gonna add and subtract the coefficients. So we have 4x, so its like term is 2x. So if we put these together, I have 4x's plus 2x's. That is going to give me 6x's. These are constant terms. They are also like terms. So -7 plus 3 are also like terms. And we can add those together, -7 plus 3, and we get -4. And now this is what we're going to be called as saying this is simplified at this point. So part of the rules of simplifying is that we like to combine like terms. We also like to get rid of parentheses as well. There's a bunch of different rules to simplifying. All right, so the next one, we can do this a little faster. So I'm just going to pick the first number. So we got 4. We need a like term to 4. This is a constant. Do I have another constant term? I do. I have -7. So 4 and -7 are like terms. We have this negative x squared. Do I have another x squared? I have it right here, 5x squared. So negative x squared plus 5x squared are also like terms. And I can rewrite it so these terms are next to each other because I'm just using commutative property. Because with commutative property, I can stick the terms next to each other. Next, we have 4y. Do I have another term with just y? Well, I do right here. I have that -2y. So plus 4y minus 2y. And then the last one, color have I not used here? That one. Do this in orange. We have a 3x. So this one is by itself. It doesn't have another like term, which is fine. It just stays 3x. So sometimes things do not have a like term. So in the end, we have 4 plus 7, that's going to be negative 3. Negative x squared plus 5x squared means I have a total of 4x squareds. 4y minus 2y. If I count all my y's, I have 2 y's. And then we have the plus 3x. So technically, you should be writing this so it goes from largest power term to smallest power term. If you're like trying to do homework and it's not accepting things, it's probably the order of your powers it doesn't like. And it should tell you that you need to order your powers. Okay, so simplifying, when asked to simplify an expression, we are trying to reduce the expression, fractions, or problems in simpler form. So with an expression, we are trying to reduce the number of operations and terms. We accomplish this by, for us right now, we are going to accomplish this by distributing multiplication or division across addition and subtraction, so distributive property, and combining like terms. So to simplify an algebraic expression, we combine like terms. An algebraic expression is simplified when parentheses have been removed and like terms have been combined. There was the term I was looking for. We can use properties of real numbers to help aid in the simplification. Okay, so we're going to run through these. So my first one here, I have 4x minus 7y plus 6x plus y plus or minus 3. If I'm looking for like terms, we have 4x and we have 6x, so combined we have 10x. I have a minus 7y plus a y put together. That is a minus 6y, right? Because I'm just adding up how many y's I have. And then the constant doesn't have a friend, so it just stays there. So that is simplified because I put like terms together and I didn't have any parentheses to worry about. So here, when I have parentheses, I want to do distributive property first. So by distributive property, negative 2 times x is negative 2x. Negative 2 times negative 3y. So if we just multiply the negative 2 and negative 3y together, and then we have plus 6x. So negative 2x, negative 2 times negative 3. So we can use the associative property and just multiply the 2 and the 3 together, and we get minus 6y. Now we got rid of parentheses. Now we just combine like terms. And the only ones we have is a negative 2x and a plus 6x. So that's going to be 4x minus y. Oh, sorry, plus 6y. Negative times a negative. All right, so here we do have a distributive property because we got this negative here. So think about this as you have a negative 1 out front. So we have 3x squared plus 2x minus 4 plus negative 1 multiplied to 8x squared minus 2x minus 1. So you're distributing the negative across. We end up with 3x squared plus 2x minus 4, and then negative 8x squared, negative times a positive, plus 2x, negative times a negative, plus 1. If we combine like terms, we have 3x squared minus 8x squared. So we have 3 minus 8, negative 5x squared. We have 2x plus 2x. So we have together a combined 4 x's. Then we have a constant of -4 and a constant of 1. Add those together, we get -3. Okay, so for your last problem, I believe this would be number 9. We have an A and a B, so you just want to, once again, use distributive property, get rid of parentheses, combine like terms, and simplify 7x plus 4 times y minus x minus 3 times y plus 1 and 4, and then you're going to have bracket 2 minus 5 parentheses 7y minus 2x parentheses bracket plus 5y plus 1. So pause for a moment and then come back and we'll have a solution. Okay, so we do distributive property first. I'm going to do this step by step. This is going to be 7x plus 4y minus 4x. So that got rid of one set of parentheses. Well, now we have this set here. We need to distribute this -3 across. So 7x plus 4y minus 4x, -3 times 2y. So the 3 times the 2 is -6y. -3 times 1, -3. So we combine like terms. We have 7x minus 4x. We have 4y minus 6y, and we have a -3. So I'm just grouping them together so they're like terms together. 7 minus 4 is just 3, so we have 3 x's. 4 minus 6 is -2, so we just have -2 y's. And the constant was by itself. Okay, so here we got to do a little extra simplifying because we got a bracket and parentheses inside of a bracket. So order of operations, do the innermost one first. So we're going to have 3 bracket 2 minus 5 times 7. So we're going to have 35y. Then minus 5 times 2, that's going to be plus 10x. Now we can do distributive property again. This might be a little different for you. So I have 3 numbers essentially being added together. I'm going to distribute to all 3 of them. So I'm going to have 3 times 2 is 6. 3 times 75 is, I think it's 105, but let me double check that. 3 times 35, 105. So that's a negative 105 y. 3 times x is going to be 3x. And now I've distributed across here. I can drop that bracket. Plus 5y plus 1. Now if I do my like terms, so the x doesn't have another x, which is okay. The y, we do have 2 with a y in them. So negative 105y plus 5y. And then we do have 2 constants. We have the 6 and we have the 1. So we're going to have 30x minus 105 plus 5 y's. That means we have negative 105 y's. 6 plus 1 is plus 7.